right, so number 6 right here is the partial pressure problem. This is just on the back side of the worksheet that you guys have already received. And you're given how many grams of two particular gases we have. We have argon and xenon. And you're calculating for what volume does the mixture occupy at standard temp and pressure. And it also says to calculate what the partial pressure of each gas is. So the key hint that you guys want to utilize here is that you're solving for partial pressure and you're looking for volume as well. But whenever you're given grams like this of a gas, that's pretty much useless for us. You want to change it right away over into moles of the gas. So you could employ the law that you guys learned in your notes. So let's do that really quickly. We have argon here, and we have 6.25 grams. If you look on the periodic table, the molar mass of argon is 39.95, and we end up with 0.156 moles of argon. Now we're going to do the same thing for xenon here. Xenon, we have a mass of 4.97 grams. We're dividing it by 131.29 grams per mole off the periodic table, and then you wind up with number of moles of xenon as well. Now, once you have your moles, you want to get the mole fraction out of this, and remember the equation for mole fraction is you take the number of moles that you actually have, and then you have to divide it by the total number of moles. And the total number of moles, these are the only two gases we have, so you just add them up. And if you add up 0.156 with 0.0379, you wind up with 0.1939. So this is taking your number of moles of argon, dividing it by the total number of moles, and then taking the moles of xenon and then dividing it by the total number of moles. And that right here, these two numbers that we just calculated, these are your mole fractions. Okay. Mole fractions are really useful when you're trying to find for partial pressure, because if you know the actual total pressure of all the gases, and we do here because we're told it's STP, and we know that at STP the pressure is going to be 1 atmosphere. Okay. So if I wanted to know the partial pressure of argon, I'm going to just take my mole fraction that I have, 0.805, and you're going to times it by the total pressure of 1 atm, and it's not going to change. So you get 0.805 atmospheres for argon. And then for xenon, same thing. We have a mole fraction of 0.195. We're going to times it by the total pressure, which is 1, and then we get 0.195 atmospheres. Right? And if you add these two up, it's going to come out to the total pressure that we already had, which is 1 atm. So this is my partial pressure here of argon, and this is my partial pressure right here for xenon. And the final part of it, it says what volume does the mixture occupy at STP. And at this point, we know all the information to plug it into a simple ideal gas law. So we're going to put it into Pivnert. We know the pressure, it's 1 atm. The volume, I don't know, so that's what I'm going to solve for volume. The number of moles, the total number of moles that we calculated earlier was 0.1939. The R constant is 0.0821. And then for temperature, you have 273 Kelvin. Okay, so you're going to take this side, you're going to multiply it all, divide it by 1, and then we end up with 4.35 liters. Another thing that you guys could use here is you could use the STP shortcut. So you know that STP, you know that 1 mole of gas occupies 22.42 liters. And you actually already know the total number of moles. It was 0.1939 moles. And we could just multiply by ratio here. You know that 1 mole occupies 22.42 liters. So if you just go through and multiply that out, you should get the same answer here as 4.35 liters. And that's all.